Assalamualaikum warahmatullahi wabarakatuh. My name is Azizul Hakim bin Abdul Kadir, and for today I will present about the introduction of our mini project, which is Automotive System Model. So this mini project consists of two different circuits that based on real car wiring system. The task is to combine all the circuits into one circuit with no error. This mini project based on our previous practical lab that have done, which are practical lab 4 and practical lab 5. So basically our practical lab 4 is about automotive relay, horn and solenoid, and for the practical lab 5 is about headlamp system. So we move to the first component, which is horn. So what is horn? A horn is a sound-making device that can be equipped to motor vehicle, buses, bicycle, train, and other type of vehicles. The sound may usually resemble a honk of the vehicles or a beep, which are applied to motor vehicles. The driver uses the horn to warn others of the vehicle approach or presence, or to call attention to some hazard. So the electronic horn are used on vehicle to give out warning signal generated by an electronic circuit. A solenoid is magnetized and demagnetized to produce the fundamental frequency and cause the diaphragm to vibrate. This generates high pressure that passes through the trumpet horn to generate a sound. A key advantage of electronic horn is the lack of wear, resulting in average lifetime 10 times higher than with electromechanical horn. So the next component is headlamp. So what is headlamp? A headlamp is a lamp attached to the front of a vehicle to illuminate the road ahead. Headlamps are also often called headlights. So two headlamps are required to be mounted as far apart as practical. Each headlamp must meet the same performance requirements. There are two primary types of beam pattern, which are illumination intensity produced by vehicle headlamp, which are the high beam or the low beam. So finally, this new project will fully be demonstrated by using Protest Design Suite, which is a window application for schematic capture, simulation, and PCB printed circuit board layout design. It can be purchased in many configurations depending on the size of design being produced and the requirement for microcontroller simulation. That's all from me. Thank you.
Okay, now so this is our objective for the mini project. So the first thing is to construct and record electrical value of the design vehicle, electrical circuit and system. Second, compare and discuss the calculation and measure value between LW and MP previously network and mini project. So that is our objective for our mini project. So I will pass to my friend. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Amir Bernan. So today I want to present about my mini project for AEE. So right now I want to present about the apparatus. In mini project we use battery, bulb, horn, relay, fuse, wire, wire connector, wire cutter, screwdriver, and multimeter. For the procedure, the first one, connection for the lamp. The fuse connected to positive terminal battery. Then the pin 30 relay connected to the fuse using two relay. High beam and low beam switch connected to pin 86 relay using separate relay. Switch connected to fuse. From pin 87 relay connected to bulb, and bulb connected to the grounding, and pin 85 relay is connected to the grounding. For the second connection is for horn. First one is fuse connected to fuse positive terminal battery, pin 30 relay connected to the fuse, switch connected to the fuse, and switch connected to the pin 86 relay. Pin 86 relay connected to pin 87 relay connected to horn, and horn connected to grounding, and from pin 85 relay connected to the grounding. This is our connection for headlamp connection and horn connection. The next one is we will see the simulation.
For the direct connection and result, the connection of the horn is direct from the battery or power supply. The voltage reading for the horn is 8.7 volt and the voltage for the wet battery is 11.38 volt. This connection will make the lifespan of the component shorter because there are no resistance that can control the current from battery to component. Okay, for the indirect connection and result, the connection will have a relay, fuse and switch that will control the horn, and the horn's voltage is 11.77 volt and the wet cell battery's voltage is 12.48 volt.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Fahmi Khalili bin Saiful Azni, and in our mini project, I selected the title Circuit Construction Horn in Automotive to elaborate. So before I continue to the circuit construction, I'm going to explain a bit about what is a horn. So horn used in general in a lot of automotive such as car, motorcycle and lorry, and even trains use a horn. So what does actually a horn do? So horn actually produce a high note sound to alert other driver in an emergency. So but a horn nowadays is a very important part or system in automotive, because most driver are not focused and easily distracted with their phone, and some drive with they are sleepy, and some even drive while they are sleeping. So with a horn, we can alert the other driver that is distracted or sleepy to gain some consciousness or to be more alert when driving. So that is basically the function of a horn. And next is circuit construction. This is the circuit construction we constructed using a Proteus. So this is similar to the lab that we use, so the diagram lab that we use in our lab. So this is the example circuit that we taken from the internet, most of it. So this is actually what it looks like in a car. In a horn system, we have a battery which is a 12 volt battery and normal battery that is used in a car, and we have a relay. This is the switch, and this is the horn. How does it work? So for the first one is the battery will supply the current to the relay, and the relay will charge with current. However, the relay will not pass the current through, because this is a normally open switch right here, which is connected to the switch, which is the steering that have a horn. Alright, so whenever we want to use the horn, we need to press the horn. So when we press the horn, the switch will close, and when it close, the current will flow. So okay, starting from the battery will flow the current through this terminal, and then the current will stuck here waiting for the switch to normally close. So whenever the user press the horn, the switch will close and the current will flow to here. So when the current flow to 30, this is the output of the output terminal for relay. The current will flow through and go through horn. So that is basically how does a horn works, and that is for all for me. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Azizi binti Syukur, and today I will be explaining about my mini project, which for the subject of Automotive, Electrical and Electronic System Fundamentals with the code of STB 35703 with the low beam connection. So here we go. So these are components of low beam lights, which, as you can see here, we have battery, and then screwdriver, relay, crocodile clips, relay casing, connector, and bulbs, and then another battery. Another battery just in case that this battery cannot work well. Okay, done for components. Then we go to connection, low beam connection. So as you can see here, the relay is quite small, but I assume that we all can see it. Okay, generally there are 5 pins for relay, which are 87, 87A, 86, 85, and 30. Okay, as you can see from the screen, the 30 pin goes to the battery, and then the 85 pin here goes to the ground. Okay, and then the 86 here goes to the switch. This is the switch. So as you can see, it is quite small. And then last but not least, the 87 goes to the lights. So as you can see here, the 87A pin is not connected to any of the components because it is not used. So generally, just 4 pins that we use in our lab. Okay, the connection is quite simple though, and it is not that hard for us to connect all this. Okay, and then this is the result of the low beam. So as you can see, the light is quite dimmer than the high beam. So for the high beam, the next video, my next friend will explain the connection, the components for the high beam. So that's all from me. Thank you.
Right, so my name is Muhammad Shafiq Muhammad Kiro Azmi. So today I will explain about high beam connection and result. So early my friend already explained how about component and result for the low beam connection. So now I will explain the high beam connection and the result. So as you can see, the high beam connection and result. So as above for the component and feature, so you can see how we construct the high beam connection, same like the low beam connection. We just put the switch for the changing low beam to high beam connection. So that is the high beam result, and then we measured use the voltmeter. So as we measure, we got a 0.092 volt for the high beam result. So that is for the high beam result. So now, okay, so now we go to the headlamp Proteus connection result. So this is our sketch circuit in the Proteus connection. As you can see, we already draw the second lamp. We have a 2 lamp for the headlamp Proteus circuit. So the result, as you can see, for the lamp 1 is 11.7 and the lamp 2 is 11.7 also. So the result is also same. So this is our headlamp Proteus connection and the result. Alright, so that's all for me.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Fatihah Shiki binti Muhammad Shukri. Okay, today I will present about the mini project circuit for the combination of lab 4 and lab 5. This is the combination of lab 4 and lab 5 for our mini project circuit. So this is the circuit that we have drawn and in the Proteus. So we have included the voltmeter to read and measure the value of voltage for horn, high lamp and also low lamp. Next, this is we want to measure the voltage for high lamp and also horn. Okay, so when the switch of horn is on, so it's connected, so the value of voltage of a horn is equal to 11.9. And when the high switch is on or connected, so the high lamp will light up and the value of voltage for high lamp is 11.7. Next, okay, for measurement low lamp, when the low switch is connected or turned on, so the low lamp each will have a voltage measurement which is 11.7 volt. And as for high lamp, the switch is not connected, so the high lamp value for each high lamp is equal to 0 because the switch for high lamp is is switch off. So when for a horn, so when the horn switch is not connected or is switched off, so the value of voltage for a horn is equals to 5.96, which is lower than previous value of horn, which is 11.9 when the horn switch is turned on. The project circuit of LED 4 contain of horns and also LED 5 contain of headlamp circuit. So we compare the mini project in the LED 4 and LED 5 regarding the measurement of voltage in the circuit. So as for the first item is horn, so for combination circuit, we have measured the value of horn, value of voltage of a horn in combination circuit of mini project is equals to 11.9 volt. And for lab 4, we have measured the horn voltage is equals to 11.7. So here we could see that when the horn is connected in with the headlamp, the value is much more higher or slightly increased instead of when the circuit is connected only with a horn without headlamp. So as for the second item, which is the headlamp, for combination circuit where the headlamp is connected with a horn, so the value of voltage for headlamp is both for high lamp and low lamp is equals to 11.7. And as for the lab 5 only where there is no horn connected in that lab 5, so the value is also equal to 11.7. So here we could see or we could conclude that for headlamp, even in combination circuit or lab 5 or only its component, the value of voltage is the same for headlamp. We move on to the calculation part. So the calculation is regarding to the components that we use, certain components that we use in our circuit. So for horn, when the resistance is 1.1 ohm and the voltage is 11.6 volt, so when we use the formula V equals IR and we manipulate the formula where we want to find the current, so the current we could get is 10.55 ampere. That is for horn. And as for horn with shunt, so when the resistance is equals to 1.2 ohm and the voltage is equal to 11.7 volt, by using the same formula, we could get the current equal to 9.75 ampere. Next, the calculation for high beam and low beam light. So when the resistance is 0.4 ohm and the voltage is 11.7 0.86 volt. So the current that we could get is 29.65. And as for high beam and low beam light with shunt, when the resistance is 0.6 ohm and the voltage is 11.4 volts, so the current that we could get is 19 ampere.
So now, lastly, I will explain what we have. The conclusion for our mini project is to extract from the work that have been done. We can conclude that this project is successful. We managed to learn new things such wire, the flash horn and headlamp connection. We also managed to learn finishing our work nice in Proteus. The most important part is that we got a lot input about car electronic system which makes us in the future in case that we have trouble with the wiring connection. Lastly, we were able to challenge ourselves in doing something new that we have zero knowledge about, and we have hope out that our knowledge will able to help the society one day. So that's all for me. Thank you.